Hi everyone, so today I'm going to be giving you a video on power. This is still on the topic of work, energy and power, so this is all going to be in the same playlist, okay? So, power, by definition, is the rate of energy transfer. And if you don't know much about energies, go on my first video on this playlist because I give you the 10 forms of energies and then talking about this thing about transferring energy. But anyway, so power is how fast you're transferring the energy. The energy is being converted from one form to another. So that means that the units for power is watts, which happens to be the same as joules per second. Therefore, the formula for power, P, and it comes in watts, so W, equals the energy transferred, so the energy in joules, divided, so the E in joules, sorry, divided by the time T in seconds, okay? Now, imagine that we're talking about something that moves, okay, like for example an airplane in here. Then I can also mention this thing about engine power, okay? So if I have an output power of an engine, I can call it the engine power, the motive power, any of these things, okay? And here in my example I have an airplane at constant velocity. Now, if my object or my powered object is moving at constant velocity, it means that the forces are balanced. And again, go on a video that I have about forces in equilibrium or balanced or unbalanced forces. So it means that the forces are balanced. So this is that the resistive forces, so you know, air resistance, any drag or friction, are equal in opposite, equal in number and opposite in direction to the motive force, which is the force that is making the the airplane, for example, to move forward, okay? And then the work done by the engine is going to be transferred into the internal energy of the surroundings by the resistive forces, okay? So, there is another formula for power, okay? So, you guys know that power equals, let me show you again, energy transferred over time, right? And you know, and if you don't remember from last lesson, or if you don't remember, go on the last video or 2 videos ago, energy transferred is the same as work done. And work happens to be the force times the distance that you moved in the direction of that force. Therefore, power equals the work, Fs, divided by t, the time. Now, S, the displacement or the distance moved over t, the time, is equal to v, velocity. So power is going to be equal to F times v. So the output power of the engine, P, is going to be F, the force, times v, the velocity, okay? So, let's think about the types of output forces that I can have, okay? If my output force is larger than the resistive forces, then the forces are not balanced anymore, right? So this is going further from the previous slide where the forces were balanced. Now, if my output force is larger than the resistive forces, my powered object is going to gain speed because the forces on the forward direction are bigger than the forces in the backwards direction, okay? If they are smaller than my resistive forces, then obviously my powered object is going to lose speeds. So my motive power, I can say as well, that is the energy per second that is going to be wasted due to the resistive forces plus the gain of the kinetic energy per second. So my power is going to be kind of the resultant of the energies that go into the form that I want. In this case is the kinetic energy. With, as I said, is the resultant, so when you add them up, taking the direction into account, with the energy that is wasted, okay? And because power is energy per second, you would have energy wasted per second, gain of kinetic energy per second, okay? Now, the last thing, the wasted here, I put it, the wasted with the... Oh, I forgot this word, but I forgot the word for this, but I put it with these things. It's not brackets, I cannot remember. But because remember, energy is converted into other forms. It's nothing destroyed, okay? But when I take or talk here about wasted is energy that goes into a form that is not the useful one, not the one that I want. And I think that's it. Yeah. Next lesson will be energy and efficiency. So here we go. Everything that you need to know about power, at least for the time being. And up to my next video, be happy and healthy. Bye!